I've updated my code here now to include a section to calculate the odd values of squares. It's pretty much exactly the same as the section above it. The only difference is related to these indices because of the direction that the even values go compared to the odd values. So as before when we were making them, for this row down here, this decreases from even square, but for an odd square such as 9 or 25, this row is increasing, and it's the reverse case for the columns. So I just had to make a few little modifications to the way the indexing worked to account for that, and then put it in. So I haven't actually tested this yet. So if we do this, I'll change n to 5. I'll put a breakpoint in and check that this actually does what I want it to. So this stuff is all working fine. Okay, the place row should go to the odd square row, which for my odd number 5 should be the first row, which it is. My column starts, it should start at the first column, and it should finish at the last one, which is the 5th, which it does. So then I should place that in the top row, which I do. So that works fine. So then my column, I should be placing in the first column, which I am. I should start in the first row, which I do, and I should finish in the last row, which I do. So my first column should now be filled correctly, which it is. Okay, and then I update my numbers, and then I'll run through to the next to the next odd case. Okay, and that didn't work. So MATLAB's yelled at me, so it says there's an error in this row, because the subscript indices must either be real or positive integers or logicals. It's line 98. Okay, I'll put a breakpoint there. So this is interesting because the first time through this loop it works. So it's complaining to me about the indices, which usually means that I'm trying to ask MATLAB to put something in a location that doesn't exist in a matrix or vector. So usually zeros or negative numbers or numbers larger than the dimension of the matrix is what would cause this. So in this case, spiral matrix is 5 by 5. Okay, so row index, column index, and column finish are all within that, so that works okay. So I'll come back to these. So the next time through, it's still 5 by 5, but my row index is 0. And my finish index is 6, which means that I'm updating these incorrectly. So I update them here, and okay, what's happened is I'm lazy and I copy pasted my code, and I can tell because this comment is the same, because this is an odd square now, and I'm updating it incorrectly. So I changed the name, but I didn't actually change the way it updates. So if I look at my comment up here, the odd square should change like this. So I should be adding one to the row and subtracting from the column. Instead I was doing the opposite. So if I run this now, the first time through it should work. So it does, and then the second time through, what's this extra thing? Oh, okay, the next time through I've got the even one in there, so I have the 16, 15, 14, which is correct. And then if I step this, I have 7, 8, 9, which I should. And then 7, 6, 5. Okay, so if I run this, I can check now this code ran the whole way through. I can check my spiral matrix, which looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this spiral matrix looks correct. I'll check that works for a different value then, like 6 or 7. Okay, it works for 6, so I'm going to hope that it works for other values as well. But I don't actually have test cases for those, so I have no basis to compare to. So because it works for 5 and 6, I'll hope that it works for the rest. Okay, so that's our spiral matrix. Now we have to find the diagonal elements of this. So we want the 4 diagonal elements and the other diagonal elements. So MATLAB, I think, has a function called diag. So diagonal matrices and diagonals of a matrix. Okay, so diag x is the main diagonal of x. So that means if I do diag spiral matrix, I should get 21, 7, 1, 3, 13, 31. So 21, 7, 1, 3, 13, 31. Okay, so I do. So that seems straightforward enough. So the next question is, how do I get this other diagonal? Okay, so what I should be able to do actually is if I flip the columns of my spiral matrix and then take the diagonals of that, that should give me the opposite diagonal values. So if I do test equals spiral matrix flip left right, it should just flip the direction of the columns. So it gives me 26, 27. That gives me what I want. So now if I do diag test, it should give me 26, 10, 2, 4, 16, 36. Which it does. Okay. So I can use this in my code now. So I can say, I'll call it the 4 diagonal will be diag spiral matrix. And the reverse diagonal, I don't know if these names are mathematically correct, but I'm just going to go with them, will be the diag of the flip left right of spiral matrix. And then I need to add all of this together, so I can do sum of 4 diagonal plus the sum of reverse diagonal, and that should be my answer. So I'll let that print to screen. So I should get the total as being 101, and I get 102. So what I need to do is look at what these diagonals actually are. So 4 diagonal, 21, 7, 1, 3, 13. 21, 7, 1, 3, 13, which it is. And the reverse diagonal is 25, 9, 1, 5, 17. 25, 9, 1, 5, 17. Okay. So what's happened is I've counted this 1 twice, which I guess in the problem definition, yeah. So this one only counts once. So for odd valued squares, will 1 always be in the center? Calculate the total 2 different ways based on n. So if it's even, then I don't need to do anything special, but if it's odd, I need to subtract 1 to account for crossing 1 twice. And I really hope that... So I'm hoping that in the even case there's not some other funny trick. Okay, so I'll run this. I should get 101 this time. Okay, so my total is 101. So now we see if I can just change this n to 1001 and not break anything. I'm also going to add a clear and a CLC, which I really should have done much earlier in this, but so I click run, and I have a number. Okay, so now let's go to Project Euler and hope that it is correct. And it is. Okay, so there's an example, a fairly long example, of how I've gone about solving this problem. So as a recap, I've started with something very basic. So remember, right at the start of this, all I did was generate an empty matrix and put one square number in it in a correct location. And then I've slowly extended that to add more functionality to this and the correct behavior. And as I've gone, I've been checking every single one of these things. So for example, at the end when I got an answer of 1001, I knew that nothing here was a problem. And I knew really that there was nothing wrong with my matrix because I'd generated it, I'd tested it, I'd seen that it was working correct for several cases. So I knew most likely there was nothing wrong with what I was generating, and the problem had to be somewhere else. And as it turned out, it was just as part of the definition. So that's all for this, and I hope this has been useful.